Okay, today you have already done your prelim practical exam paper 2012. Alright, so now I will demonstrate to you how to carry out this experiment, and then what the test is important for you and how you should do your observation recording. Okay, first and foremost, when you go into an experiment for an exam, a practical exam, you are supposed to read the headings very carefully. Alright, you are provided with solid X, Y, solution Z, solution of a metal salt. Okay, you are also given potassium manganate 7 solution, oxidizing agent. It will be decolorized when it is reduced. So when you see oxidizing agent, you must have some rough idea that you are actually carrying out a redox reaction. You can write all this down, no problem. In fact, you should. Alright, carry out the following experiments and test any gas evolve. Alright, I see a lot of you did not test for the gas evolve. Okay? Alright, after reading, you're supposed to read what you're supposed to do. Okay, after reading, you're very clear, then you start your experiment. Alright, so before you start any experiments, you should start washing your test tubes. Alright, test tubes during the actual O-level and prelim, we will try to give you clean new ones. But because daily experiments, you are using your own test tubes, it may be dirty. Alright, so you got to wash them with distilled water. This is how you wash your test tube. Okay, I'm washing 4 of them. I'm leaving some of them dry, just in case I need to do heating. Alright? Please put all your test tubes in the rack. Okay, if not, give you rack for what? Right? Okay, number 1. Place 2 cm cube of potassium manganate solution in a clean test tube. Okay, this is potassium manganate solution. 2 cm cube, just give an approximation. Alright, it is purple in color. Okay, add 2 spatulas of solid X. Stopper the test tube and shake thoroughly for 2 minutes. Alright, 2 spatulas of X and leave the test tube to stand for 15 minutes. So this is a spatula. Alright, supposed to add 2 spatulas of it. Okay. Okay, let it stand. Okay, you can actually wash the wall with the distilled water. Alright. Okay. Alright. Okay, leave it to stand, so don't disturb it. Okay, leave it to stand for 15 minutes. Then, if we do not need to do anything, you just leave it there. Okay, and proceed on to part 2. Alright, so what do you realize? Okay, there's a change in color, right? Okay, but some of the X hasn't dissolved yet, so you leave it there. Okay, you do part 2. Dissolve the rest of solid X in a large test tube with distilled water to about half full. Okay, so this is your boiling tube. Okay, the rest of it, you can actually pour inside. Add distilled water until half full. It's half full. Alright. Shake it thoroughly. Another way is you use the glass rod to stir. Add some more if you need to, it's okay. If they say half boiling cube full, you add a bit more, it's actually okay. Alright? Yeah, so what do you realize? Okay, so if you think you can record, you record. By dissolving a solid in water, you also need to do recording. Okay, so how do you write? How do you describe this solution? Colorless solution obtained. Okay, 1 mark. Okay, so you'll leave this on the rack. Okay, alright. Transfer 2 cm³ of solution X. This is called solution X now. Alright, solution X. Okay, 2 cm³. Add two drops of, okay, you're supposed to hold a test tube with the test tube holder, right, so that the chemicals will not get onto your hand. Okay, that's about 2 cm³. Alright, what is the use of using a universal indicator? Yes, a universal indicator is for you to check whether the solution is acidic or alkaline, depending on the color change. What is the original color of universal indicator? Yes, green. Alright, drop 2 drops. Okay, how should you describe? Okay, so this is how you should describe. Who do you describe? Do you describe universal indicator or the original solution X? You should describe universal indicator. So you should say green, universal indicator turns red. Okay, so from here, later on you are supposed to make some conclusion. In fact, you should take your pencil Alright, because it turns red, what can you conclude? Solution X is acidic, right? Yeah? Okay, so these are the things that you can write along the way. Okay, next, moisten the end of a splint with distilled water. This is called a splint. There are still people who don't know this. Alright, moisten it. This is how you do it. Moisten it. Okay. Alright. And dip into solid white. Okay. This kind of test is called a flame test. You are supposed to observe the color of the flame and record it down. A lot of you actually wrote down this solid turns black, which is not the case. Not supposed to be the case. You're supposed to write down what is the color of the flame observed. Alright, so you start a Bunsen burner. how do you light up a Bunsen burner? Put it this way, not this way, okay? Put it this way, alright? Adjust the air hole, it's supposed to be closed first, so you get orange flame, right? Okay, then you slowly open, and then you burn. What is the color of the flame that you see? Okay, I hope you all see. Wait, okay, not so obvious, right? Can do it again. Wait, I get a new one. Okay. One more time. This one. What is the color of the flame you see? Red, right? Red flame. So, turn off the tap before you do your writing. Yes. So, how should you write down? Red flame is seen or observed. Simple enough. A red flame is seen. That's all. Okay? Now you go back to your part 1 and then you check. Okay? This is the final color. Alright, how should you record? Okay, what do you realize? What do you realize has happened to the solid X? Alright, I have some leftovers, but most of the solid X has dissolved. So you should say solid X dissolved. Alright, and you're supposed to say the original color, purple, potassium, manganate, 7 turn. What is this color? Pale orange? Yes. Okay. Alright. Or you can write decolorized, but in this case you have color, so you write the color. Write down what you observe. Alright, eventually it should be decolorized. Okay, so far so good. Okay, then you can do B part 2. Place 4 cm cube of solution X in a clean test tube. Add half a spatula of solid X into solution X. Solid Y into solution X. This is the part where a lot of you have a lot of question mark. What do you deduce from here? Solution X is acidic. What happens when you add a solid to an acid? Please recall your acids, bases, salts. What are the 3 main reactions of acid? Metals with acid, carbonates with acid, and alkali with acid. But in this case, you are adding a solid Y. Does solid Y look like a metal to you? No, not metal. So, what could solid Y be? Could it be a carbonate? Highly possible, right? Could it be an alkali? Not possible, because solid Y is not in the solution form. So we did not provide you with an alkali. So not base, not alkali, alright? Okay, so if we ask you to do this, you must look out for what? Bubbling. Alright, so you must be able to predict. If you add a carbonate to an acidic solution, yeah, what are you anticipating? Carbonate. So you are anticipating carbon dioxide. Yes, so what must you prepare? take a test tube. Okay, add lime water to it. You do not need a lot. Like this is enough. Okay. Then take a delivery tube. A lot of you still don't know how to put the delivery tube in or out. Which side? Okay. Wash the delivery tube first. Okay, very simple washing. I see the way y'all wash is like a big job. Okay. Place the long part into the lime water. Okay, so this one you on standby. Put it there. Next, then you place 4 cm cube of solution X. Okay, put your test tube holder. Test tube holder is not supposed to be too high, too low. It's supposed to be slightly above the halfway mark. Okay, pour about 4 cm cube in. That's enough. Okay, and add half a spatula of Y. You look at Y. What does Y remind you of? Yeah, it is not a metal. How can a metal be white powder? Alright, so it's highly likely to be a carbonate. Okay, take half a spatula. And you see a lot of bubbling, right? You quickly stop it. Release it. Form an A shape. Inverted A shape. Yes. You shake this side to create more bubbling. So what do you see on the lime water? White PPT, isn't it? Yes. So what is the gas that's evolved? Carbon dioxide gas. So you all must work very fast. If not, all the gas will be gone. Then you have nothing to test for. Alright, so you see, the white precipitate is very prominent in the lime water. Alright, so how do we record? Okay. So this is how you record. Effervescence. Okay, if you have difficulty spelling this word, never mind, just say bubbling. Effervescence of colorless, there's no smell, odorless gas. Okay, gas produce a white PPT in lime water. Effervescence gives you 1 mark. Gas, you test for the gas, another 1 more mark. A lot of you just write gas produce and you never test for it. No test, no observation, you do not get the 2nd mark. Okay, simple as that. I see a lot of you testing oxygen lah, hydrogen lah. That means you don't even know your basic well. You don't know your theory well. If not, you wouldn't need to spend time testing all the unnecessary gases. Okay? Fine, ah? Alright, let's go on to part C. Place 2 cm cube of solution Z in a clean test tube and add dilute sodium hydroxide dropwise. Okay? Alright, dropwise means they ask you to add a little bit first. What does this? Until no further change is observed. Add dropwise first, then until no further change. This one is only when in excess. Yeah? Add dropwise first. This is called adding dropwise. Okay, maybe I use too much of the solution. Hold on, ah. This one reject. Okay, I do 1 more time. 2 cm cube. Okay, 2 cm3, a little bit is enough. Sodium hydroxide. Okay, if you see very clearly, there is supposed to be PPT. Okay, people, this is a blooper. I use solution X instead of solution Z. Okay, so pour away. Blooper. Okay, don't follow me. Never mind, keep calm and then continue. Okay, wash your test tube with distilled water. Okay, wash your test tube with distilled water. Okay, so now solution Z. Okay, so I'm supposed to test. So what is the use of sodium hydroxide for? Is for you to test for cations. Alright, so what do you expect to see? What is this? This is called white PPT, right? Okay, so this is how you record white PPT form. Yes, PPT is allowed in practical, so you can write PPT. White PPT form, and then what are you supposed to add? Until no further change is observed. So you add until about half a test tube full. This is called in excess. So thereafter, don't just leave it there. You're supposed to shake it thoroughly and check whether the PPT dissolves or not. So in this case, is the PPT soluble in excess? No, I don't think so, right? Okay, so white PPT form, insoluble in excess equals NaOH. Simple, 2 marks. In front white PPT 1 mark, insoluble 1 mark. Alright, clear so far? Okay, this is what you do in actual exam. Next, solution Z in a clean test tube. Alright, and add dilute nitric acid. Okay, dilute nitric acid, the use is just to remove any other unwanted ions. Okay, it's just to remove any carbonate ions that could be present. Alright, add already. What do? Barium nitrate. Recall, what is barium nitrate used for? Yes, it is to test for the presence of sulfate. By right, you should see white PPT, right? By right. But do you see any white precipitate now? No, you don't, right? So when you don't, how do you record? No PPT form. Alright, you should say no PPT form, no PPT observed, or say no visible observation. You are not allowed to say nothing happened. If you say nothing happened, you will get 0 marks. Alright, acceptable ones are only no PPT form, no PPT observed, no visible observation. Okay, good. Next, add dilute nitric acid. Same. Add Z first. And add dilute nitric acid. Okay, and add silver nitrate solution. What is silver nitrate solution for? Silver nitrate solution is for you to test for the presence of chloride. Yes. What do you expect to see? Yes, you will expect to see white PPT, and true enough, you see white PPT here. Do you even need to add in excess? No. Test for anions, there's no need for you to add in excess. Add in excess is only for sodium hydroxide solution or aqueous ammonia. Alright, so you say white PPT form. That's it. Happy? 1 mark. Alright. Okay, next. Add 4 cm cube of solution X from part A in a clean test tube. Okay, 4 cm cube. So I transfer, yes, this is my solution X. Okay, I'm not using the wrong one now. This is my solution X. Okay. Followed by 5 drops of solution Z. Okay, if they want 5 drops, I use a dropper. Okay. Alright, 5 drops. Okay. What do you see? Yes. So long you cannot see through, light cannot pass through, it is a white precipitate. Alright, colorless is only for like this. Colorless, colorless, light can pass through, light cannot pass through is a white PPT. Alright, so white PPT form. Are we done with the experiment? Yes, we are done with the experiment. Okay, so this is how an experiment should be done. Alright, don't panic, just do it properly. Alright, next is the recording, or is the conclusion. Consider the results of your experiments, write the formula. A lot of people never read formula of one ion that may be present in solution X, Y, and solution Z respectively. So let's turn back and look at our solution, our solid X. What were the tests on solid X? Basically, solid X, the tests are all here, right? Okay, solution X. So these are all the tests on X. Green universal indicator turns red. So you have already concluded your solution X is acidic, right? So to make a solution acidic, what is the ion present? Yes, H plus. With the presence of hydrogen ions, it will make your solution acidic. So what is the evidence here? Evidence, you got to say in A part 3, green universal indicator turns red, indicating solution X is acidic. Alright, this is one evidence. Okay, either way, you can also say that in this also can. B part 2 also can. Alright, when you add a solid to a solution and you get carbon dioxide gas evolve, so you can also conclude. So in B part 2, okay, or this is either or. Okay, in B part 2, solid Y reacts with solution X to produce carbon dioxide, okay, which gave white PPT in lime water. Yeah, okay. Are we good? Yes. Alright. How about solid Y? What were the tests on solid Y? Solid Y, not many. Okay? Only this part is quite conclusive. So what does solid Y contain? Yes, we have already have some planning here. Alright, we already predicted that it contains a carbonate. So what is the formula of the ion? Yes, carbonate, CO3 2 minus. Alright, so you say in B part 2, solid Y reacts with solution X to produce carbon dioxide, which gave white PPT in lime water. Good? Yes. How about Z? Okay, the last few tests are all on Z. Okay, so you can actually have more freedom to say what does it contain. Alright, Z from here, white PPT form insoluble in excess aqueous sodium hydroxide. So from here, how do you conclude? Alright, when you add aqueous sodium hydroxide, white PPT form insoluble in excess could be calcium, ion, Ca2+. Can it be Pb2+? No, it cannot because it's soluble in excess. Can it be Zn2+? No, it cannot. So what is the conclusion? Yes, it contains Ca2+, right? Yeah, so if you say it contains Ca2+, you will have to explain using the correct test. Alright, so if you say Ca2+, you got to say in C part 1, okay, white PPT was formed when aqueous NaOH was added and insoluble in excess. Or you have more freedom, you can also quote what is the anion present. So you tested this, right? C part 3 with silver nitrate and you got a white PPT. So which anion is present? Yes, chloride. Or you can say Cl minus. Alright, so in C part 3, okay, white PPT was formed when silver nitrate solution was added. Okay, Sec 4s, are we clear? Okay, this is how you answer those evidence and conclusion part. Alright, this is very common in O-level practical, so you must practice. Alright, and in B part 2, based on your observation from A part 1, what can you deduce about the nature of solid X? So you add solid X to your KMnO4. KMnO4 is an oxidizing agent. So you learn under redox, who shall pair with an OA? Yes, your solid X must be an Ra, a reducing agent. Reducing agent paired with oxidizing agent, it will produce a color change, right? So this is how you conclude. Solid X contains a reducing agent. Alright, that's it. Okay, your whole practical exam is complete. Alright, so before I close the whole video, alright, you have been given practical notes suggested phrasing for observation, and simple experimental skills. Please go and memorize how you should do your recording and what is the relevant conclusion, so that in the exam you can try to predict before you start an experiment. Am I clear? You're supposed to go and remember how to write. For example, just now flame test, right? What color flame is observed? Yes, I follow this. Yeah, green universal indicator turns red, so unknown solution is acidic. It contains H+ ions. Yeah, so these two already appearing in this experiment. Alright, please use this. This is supposed to be the blue color piece of paper that you have. Alright, mine is white color. Okay, that's all. All the best for your practical exam. Thank you.